Hello,
Hello.
YouTube, LinkedIn, Twitter, and Twitch. Today we'll be making Raspberry Jam. To catch you all up, in the previous episode of Topl the Grid, we got the blockchain node working. As we like to do, let us break it. Again, for data and science. The Topl team is glad to have you all here, watching and learning as we go. Before we introduce the team, we have a massive grant program going on. And would love for you to check it out and find all the information on our link tree or topl.co. Now, let's introduce the team. We have James, our CTO. James, you'd like to say anything? No?
Hello.
All right. And Sean, our senior blockchain engineer.
Howdy, howdy. I'm waving right now. Can't you tell?
And myself, I'm Brad, the technical operation manager, and we may have other Topplers join along in the live stream. So, Sean or James, over to you two.
Heck yeah. Let's break something today. It'll be fun.
Let's do it.
I do that every day. Do a lot more
It's-
breaking than I do fixing.
Breaking things is so easy.
For real. Okay, so yeah, as Brad mentioned, we got a blockchain node running on a Raspberry Pi in the last Topl the Grid session. It was running on a Raspberry Pi, and it was talking to a virtual machine running up on Google Cloud, which was also talking to my laptop. And then we also threw James's laptop into the mix, so we got like one little mini network of blockchain nodes all talking, all communicating, all maintaining consensus. And there were a couple of hiccups along the way. A couple issues that we discovered. We got some of them worked out. One of them worked out by our new teammate, Oleg. So thank you for that. Awesome work. And so now hopefully we can come up with blocks that have, well, more than one transaction, which was kind of an issue. So for today, we're going to do that. We're going to make blocks with more than one transaction. In particular, we're going to see just how many we could stuff into a block and still have this thing maintain consensus and hopefully not start a fire my Raspberry Pi. Although that wouldn't be such a bad thing because it is freaking cold up here. And unfortunately, that is why you did not see my camera outside. I'm not in my workshop today. It's not running off a Ryobi battery this time, but it is still running off a battery. Don't you worry. It's running off of a... I don't even know the brand. Chafon. Yeah.
That sounds like a when you cycle, you use this thing called chamois cream to help prevent chafing. Chafon sells like a type of chamois cream. Sorry, I know that was a little bit oversharing. So we're here about learning. So
stay tuned for the future where James hops on a bike and he's going to power a blockchain node. It's going to be awesome.
I'm gonna have to have a chamois cream.
Yep. Make sure you bring it. Alrighty. So how do we want to do this? Like always, I don't have a plan. I'm like the Joker. Let's share a screen.
I was thinking, do we have a specific branch that we're doing? Do we have a broadcast branch?
Yeah, if you want to, it's not a broadcast branch, but it is called, what did I call it? Tetra-TX-Gen.
All right.
There you go. That's just the branch that I am currently working on for this transaction generator. If y'all tuned in yesterday, we were building out a little tool today that'll help us destroy my Raspberry Pi. I wanna ruin this thing. I'm just kidding. They're really expensive right now just because there's a limited supply of them, so I don't want to break it. But we probably will, and it's okay. It's for science.
I have to get my little. Is it a 4? I have a 3 that we might be able to add to the mix. If you're interested sometime.
So that's where things get a little bit tricky. The Raspberry Pi 4 is 64-bit, and I think that the Raspberry Pi 3 is 32-bit. It might still work. I don't know. I haven't actually tried doing that on a 32-bit machine with a JRE.
Yeah.
I know that it would not work with Grail native image, because you can only do 64-bit stuff. Yeah.
Okay.
Learned that one the hard way. at a previous project.
I feel like I might have gotten it to run in the JVM before, not recently though. But I feel like I have gotten it. I did do it once.
Yeah, yep. Like it's probably still doable using a normal Java runtime environment.
Yeah,
like any other
it was
JDK.
a while ago though. Yeah.
Honestly, I think that the hardest part is going to be building the node, and that like.
Oh,
I mean, like always,
it
that's the longest part of the Raspberry Pi. Like demoing this on a Raspberry Pi, it takes forever to build it. So luckily, I did that right before.
Go. We have to put our Raspberry Pis in the freezer while they build.
For real. Okay, so yesterday I was working on a utility, and the goal of that utility was to be able to generate a bunch of fake transactions. Well, by fake I mean real. Like they need to be validated, and they need to like actually, work on the blockchain. You can't just come up with junk data because the node will reject it. So we needed a utility that can generate real transactions, and ideally a lot of them, and ideally like an unlimited number of them. And so still a work in progress, still working on it. But I have something that will hopefully be able to stress test our Raspberry Pi. Not that that's very hard to do. You just run SBT and it's really stressed out. It's amazing. Okay, so our goal here. In the beginning, we have a Big Bang block. This Big Bang block has a single transaction in it. And that single transaction technically contains several outputs, like things that can be spent. For the sake of argument today, let's just say that the Big Bang block has a single transaction that has a single output. This output is a poly box. Sorry for using the name poly and arbit. For the sake of this broadcast, I'm probably going to have to continue using them, but stay tuned. Might get different naming. Anyway, so this is a single poly output that can be spent. Its quantity is 10 million. So there are 10 million polys in this little box that you can spend. This box is freely spendable, meaning it is locked by a height lock of 1 for this proposition. So as long as the blockchain's height is greater than or equal to 1, then this box can be spent. So our utility takes that one box that can be freely spent and it splits it. It takes it, it spends that box, that 10 million poly box, and then it splits it up into two different boxes, 5 million polys and another 5 million polys. Now all of a sudden these two boxes are now available to be spent in the protocol. And then the utility goes and takes those two boxes and splits them again. New transaction, spends one of the boxes here, splits it into two. Then the other one, same thing. You have a transaction, takes that one output, consumes it, and then creates two new outputs in its place. And then we just keep doing that over and over until eventually this quantity reaches 1, and then it tries to divide it again, and it reaches a 0 quantity, and then it gets rejected for syntax reasons, and that's where the experiment falls apart. I think. We'll see. Might get there today. Okay.
Could we maybe detect that and make that the output of that transaction is just a 1, but it's to a provably non-spendable address?
Yeah, so like definitely things that we could do, make it better, and maybe even today, like on the fly in the broadcast, we like that. That's part of what I'm hoping to be able to actually implement.
Yeah, for sure.
For
sure. Yeah. This is cool. I really like this. This is a good idea. A really easy way to do the parallel processing thing that we were talking about this morning too.
Right. Yeah.
Start multiple heads. Yeah.
Exactly.
Cool. Sorry. I'll let you keep going.
Well, I'll also note here. Let's pretend that these are all value or quantity of 1. Well, maybe our utility can go and take these and start combining them back together again until we reach, a single poly box of 10 million, and then we split it back up, and we just keep doing that for infinity.
Oh, that's cool.
So yeah, lots of options.
Dude, wouldn't it be cool to actually? I'm sorry, I just had this idea, to see if we could somehow induce like a breathing mode in the network. Like maybe we could see, because essentially what you're talking about is like a breathing mode, right? You're increasing the amount of data in the network and then you're decreasing it. So could we see that in would it hopefully our leadership election isn't, we don't see a breathing mode there, I hope, but you could definitely probably see it in the like peer-to-peer or the like network latency. Someone was, Zucky was telling us about, I think that, I really hope that's how you say his name, was telling us about in the peer-to-peer side, you have to be very careful about like big transactions or blocks, like basically leaving a like trail of like, as big things move through the network, they leave like a trail of disconnections behind them, like kind of like a wake, because they, as nodes process them, they stop responding to other requests, and so then peers drop connections with them. As, I don't know, I just kind of picture it as like a, big pieces of data. If you don't handle them correctly, or potentially, like they can be like, like ships moving through water. They just leave like a trail, and so maybe that's what we could see here is like we induce a certain frequency, and so especially when you control a frequency of a signal, it's really easy to pick out from a noise because you can basically lock into that frequency, and so you can see the effects of your demonstration in really really noisy data because you lock into the frequency that you are like stimulating at. I love physics. Oh my God. I'm sorry. Just please. But I'm just like so excited for the future of what we're going to be able to do. This is phenomenal.
Heck
Please keep going though.
I think what you mentioned did just happen recently in Lightning or something. Someone made it. Yeah, I linked something. I only saw a little bit about it, but someone created a transaction with like a ton of outputs. So it was a massive transaction. And that transaction took like so long to transmit and propagate that like they missed an eligibility or whatever for a block, and it like stumbled basically.
And everyone freaked out. It just like stalled. Didn't it like stall the whole channel and like really till everyone could like re-agree on the? It didn't seem. It didn't. The article though, it didn't say what the exact issue was, and I just didn't go do my research either.
Yeah,
that's maybe they were like really tight constraint on the time or something. Yeah.
Yeah. But it was really interesting. It was like, oh crap, we got to deal with that, don't we?
Oof, networking's hard, man.
Yeah. Okay, so yeah, this is the current state of the utility. It just keeps splitting transaction outputs over and over until eventually we have a whole bunch of these, like UTXOs to be spent. So it really fills up the data, I think, hopefully. All right, so that's our utility that we started working on yesterday. This is what we were looking at here, like the code for it. This is what we implemented. Sorry, not. Yeah, this one actually. I modified it a little bit. We're going to slow it down so that it's only one transaction per some duration, and this is what we're going to tune today, so we can control the rate if we need to. But then in addition, I went and created a few other like supporting things because all we did yesterday was created like a stream of transactions, but we need to actually send those transactions somewhere. So that's what a Topl RPC transaction broadcaster just wraps around a Topl RPC. So like a Topl gRPC client, and it submits transactions to it over and over again. And in addition to that, I moved this thing over to the right now. Thank you, Fernando, on our team. You showed us this neat little trick. You can move this thing over to the right, and then all of a sudden your little text editors don't shuffle around anytime you do this. So it was really handy. Okay. So yeah, so this wraps around Topl gRPC, and then one more utility here that takes multiple transaction broadcasters, and it just round robins them so that we don't have to like broadcast all of the transactions to a single node. We could round robin them RPC into different nodes, just to make it a little bit more realistic. And then finally, a little application.
Sorry, I mean to butt in. I just want to maybe prepare my system or get it going while we're doing these next steps. Is it just SBT space tetra node, or is it node / assembly?
It'll be here. Let me do that in a terminal. Actually, it'll be SBT node tetra / assembly.
Oh, that's what this node camel case. Oh, that's what I was forgetting. Thanks, sir. Appreciate it.
Yep, no problem. So yeah, this command here produces a jar file that makes it a lot faster to run it, because we're probably gonna have to shut it down and restart it a few times here.
I mean, if you want to, do we want to like invite people to try and follow along with us?
Oh, y'all, if y'all want to, go for it, because I am going to I've got our GCP instance running here again.
Nice.
So I'll be able to share that IP, and y'all can DDoS us, completely ruin our broadcast. Stream snipers.
I mean, it'd be a good. Come, please. Normally, you have to pay for that kind of like malicious intent. So, if someone wants to come try and ruin our day, and we can learn something from it. Heck yeah.
Need help baking this Raspberry Pi here.
Exactly.
We're gonna cook it, 450 degrees, in my RV. Okay, so
That's gonna be the energy source that we like export to Europe to help out in the winter.
heck yeah.
These Raspberry Pis building.
No, export it to me. It's cold already.
Binaries.
I need those. Okay, so yeah, so if you just ran that command here, let me just hop over. Okay, so yeah, if you just ran that command sbt node tetra /assembly, then it's going to do a whole bunch of things in the console to build a jar file, and then that jar file is going to be located in node -tetra /target /scala underscore. It's gotta be capital. Scala -2.13. Sorry. I think it's in here. Yes. So I've got like a couple in here that are lingering from previous ones, but it'll be the one that's based off of the commit, like the git commit. So in particular, we're working off of this commit right here, E58 blah 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 blah. If you have multiple in here, you could just ls-la and you can look at the timestamp. So this is the one that we want, and as long as you pull the branch that we're working from, then it should be fine. Now what I like to do is take that jar file and copy it into a directory that I can reuse. So I'm just going to go back there. I already copied it. I'm not going to do that again. But I copied it into a temp directory inside of my home directory. And here I've got the jar file, and I've got a configuration file. And so if anyone's following along, you'll need to modify a few things here in a config file. So you could just make config.yaml anywhere, and just need to be able to reference it. Okay. For now, let's just have one staker. So it would be, it would look like this. Yep, go ahead.
Just to confirm, you said the commit, the first tag is like E58D?
Yes. Yep.
Echo 58 Delta. Yeah.
Exactly.
Cool. Okay, thank you. Just make sure.
Is there a way to, not from git status? Oh, I'm not in. Does anyone know if there's a command to get the current commit hash of your branch?
Git log -in1.
Is that it?
A way. I mean, that's how you get the head. That you can just like return the log of just the head.
-n1.
It presents it, but it's not.
Yes, that's good enough though. So this gets you the commit hash. And so this is like the jar file you're looking for. It'll begin with these whatever digits.
Yep. I just want to make sure because it's still called 1.11 because that's the major release.
Yeah, most recent tag.
Exactly. Oh, most recent tag. That's kind of like your idea of from this morning because maybe we can just start focusing on the newer release, the newer tags.
Oh, gotcha. Yep. Yeah. Okay, so yeah, so if you have a jar, then I mean, it's optional to move it into a directory. You don't have to. I like to do that just to keep it simple. Once you have a jar, then you create a config file. And a few of these you don't need to do. A few of them you'll need to do. You can ignore the P2P bind host update because you're not going to accept any inbound connections. You're only going to initiate some. But the ones that you, because you don't technically need it, but you might if we change it, is this big bang and then staker count. Just set that to 1. Actually, I don't know why I'm showing you this file. I should show you the one that I'm going to be using.
Yeah. Also, I don't know for anyone else, but it's if you would you mind zooming in like 2 clicks maybe? Or it's okay. Maybe it's just.
Oh yeah. Here we go.
Oh, there we go. Oh, that's so much easier. Thank you.
Okay. All right. So yeah, let's change some of these. We're only gonna have one staker, and it's going to be the Raspberry Pi. Let's make it brutal. So if you're following along this timestamp, you're going to need to update this again in a second once I launch a node. But you can just stub this in for now. Next one is this local staker index. I'm going to use 0 on this Raspberry Pi, but you'll use -1 if you're just following along. And then staker count is going to be 1. We're only going to have one staker, just this Raspberry Pi. Okay, now P2P. You're going to need a known peers. I'm going to need to change this to 34.136.179.216. And so this is the IP address of the virtual machine running on Google Cloud. And then next up is going to be protocols, and then 0, and then set the slot duration to 250 milliseconds, or 250 milli.
All right, I think I'm good. And then just let me know the timestamp whenever you're. Oh, the first few digits are going to be the same though, right? 166509, at least that much.
Probably. Most likely, yeah. Okay, and then I need to update mine as well. I'm going to be -1. Okay.
166.155.
Okay. So now I'm gonna hop over to the virtual machine, and let me just double check in here. Slot duration is 250 milli. Staker count. I need to set my local staker index to -1. So now I need to run this from Google Cloud first. And that'll get me a timestamp. Well, it's going to launch the node, and it'll get me a timestamp. Okay, so the one that I was looking for, of course, it's split into 2 lines. Thank you, Google Cloud. That's perfect. Okay, I'm going to hop back over. I'll make this a little bit bigger so that we can all see it, but this is going to be the number. I was hoping I was going to make that bigger. Do that here. There we go. So there's our timestamp.
Wow, changed more than I thought it was going to. 1666 2832 65978 65978. So I got 1666 2832 65978. Yeah.
Hopefully.
All right. Try that.
Okay. So no blocks have been made yet because none of the stakers are active. So let me spin up the Raspberry Pi. And this should start making blocks. And I'm SSH'd into the Raspberry Pi. Whatever, we're just going to have to watch it from SSH. I do have it running. I used to have OBS open. Never mind, it's let me wiggle the mouse. There we go. So the Raspberry Pi is running. I'm just using this in a different shell, so that's why there's no output there, but it's, you can see some here. Okay, so it looks like the Pi is minting blocks. Looks like we are receiving those blocks up on Google Cloud. And then let me try running this. Let me make sure I got the right path. Yep.
Well, I'm looks like I just bootstrapped. I'm at height 24. Yep. Height 26. Height 27. 28. 29. Oh, okay. 29.
Awesome. Yeah, I do see that we got another inbound connection. That's probably me. Yeah, okay. That was just me. Oh, I did also update the logging, so now you can see which peer some of these things are coming from.
Yeah, I see that. That's cool. I like it.
Okay, so that means that we got the Raspberry Pi making blocks, and then 3 nodes are helping just distribute things. Oh, we had a request for the timestamp. You go ahead and share that. Probably just went out to all the channels.
Man, I really want to. Oh, every time we do this, it makes me want to like SSH into other machines and like get them all connected to the thing. I cannot wait until that first time we get to execute a test net of like, 10 to the 4 nodes. Oof, that's going to be a day.
Even more fun is when we get our actual network of 1 million phones.
We can. I think it's possible.
Okay.
It's the fundamental limit is we can have 10 to the. How many topls do we have? Like we have nanotopls. That's the smallest unit, right? So it's like what? I think it was the biggest number was like 10 to the 38. So we could support 10 to the 38. That would be the ultimate limit would be to support 10 to the 38 individual node operators.
Not a problem.
Can you imagine like the size of the like internet, like the how much bandwidth that network would have to be able to support for 10 to like that's literally like a universe-sized computer.
I like it.
Oh, now I'm thinking about Douglas Adams.
Okay, so I'm not sure if anyone else wanted to try connecting before I blast some transactions into this. But I'm going to go ahead and do that here in a moment. Okay, maybe let's start slow for the first experiment. We're going to throttle this. So instead of 10 per second, let's go 1 per second. Let's be reasonable here. Okay, so how this is going to work, I've got my local node running here on my laptop that you see scrolling down here. This is communicating up with the Google Cloud Platform VM, which is then communicating with James's laptop and the Raspberry Pi and anyone else who happens to be connecting to us live on the broadcast. Let's push this thing over. So I'm going to broadcast to my local laptop. My local laptop is going to gossip those transactions up to the GCP VM, which will then gossip them further to the other nodes in the network, in particular the Raspberry Pi, which will then include those transactions into the block.
Can we host multiple screens at once here, or is it limited to one screen at a time?
I think multiple people can share, but only one can be visible at any given moment.
At a
But
time? Okay.
Yeah, we can
No.
easily hop back
Okay.
and forth though if you want to.
Yeah,
So-
well, I was going to see if we could do like a little overlay thing, but it's not a problem. I pulled up my just computer usage. I was going to see if we can actually see as we start to ramp up, if I can actually see it in my OS level monitoring of the network usage.
Oh yeah, that'd be cool.
Yeah, so I'm going to watch that. I was thinking about doing an OBS window to pull it out, but if we can't do multiple, it's not a problem. But yeah, so whenever you're ready.
I mean, can I do? Well, I don't think I can do.
It's going to get obfuscated, right? Because it's going to be both inbound and outbound. Well, maybe you can see it though.
A little. Dang, this thing's not even using a bulk of my CPU.
Mm-hmm.
I was trying to find, whatever. Yeah, I can't get specific for the process, unfortunately.
Well, I am sitting at 0% network utilization.
Wait a minute. I wonder, can GCP tell us this in the logging, how much it's using?
Ooh. Currently, I'm using 164 bytes per second. Dang, that's pretty cool. That's just the base. I mean, one node talking to us, and I'm sitting at pretty consistently 165 bytes per second.
That seems low, because headers are like a kilobyte, aren't they?
Yeah, a kilobyte, but what's your block time? It's probably still 5 seconds, right? 6 seconds. What's your VRF config?
Oh, maybe it is. We can look in application.conf.
I feel like if it's a kilobyte every 6 seconds, that seems about right. 160.
I mean, this is close to 1 per second, as far as I could tell.
What do you mean the transactions? Are the transactions getting picked up?
No, the head. Oh, I haven't started the transaction thing. I just mean it looks like it's producing 1 block per second, in the logs, in that ballpark.
Oh, you're right. Yeah, it is going pretty fast. I thought it was ones per second. Yeah.
Here's the config, except for slot duration, of course.
Oh, right. I forgot we set our slot duration at 250. So it's a factor of 4 faster. Yeah, it should be actually 6 divided by 4. So it should be at around 1.2 seconds then, which I think you're right. It seems to be about around a second or so. Dang, man. That's crazy. But yeah, I don't know. Maybe that does seem a little weird, the resource monitor, though.
Received 2.27. Is that kilobytes? Kilobits. I don't know. I can never remember the difference. It doesn't matter. Who cares?
Yeah. This is why we got smarter people
exactly.
than us to figure out how to make sense of all these metrics.
I didn't want a full screen. Okay, anyway, I'm stalling. Let's get this party going.
I'm sorry, I just noticed. I'm just looking at my thing. I had a connection to 1.1.1.1, all spelled out. That was weird. Maybe I got some spam on this computer.
Isn't that an alias for 8.8.8.8? Or no, who is one? I think it's Cloudflare, maybe. Someone owns that. Or I'm making that up. I don't know. Don't listen to me.
Yeah, probably. We all know you're a liar, Sean.
Yeah, me too.
Your default
Especially I
behavior
know
is
that
adversarial. We know.
for
We
real.
understand.
It's accidental. All right, sending it.
Send it, bud. Let's see. Oh.
It's got to build.
Let's build. Okay. Yeah, we haven't seen nothing yet. I'm sitting at 20 TCP connections and about a megabit per second overall, it seems. Oh, okay. Yeah. It just rechanged the scale to 10 megabits per second. But I'm only using a little bit of.
Well, it's inserting transactions somewhere.
Well, I did see like a noticeable uptick. I basically did double my. I went from about 1 megabit per second to 2 megabits per second.
Oh yeah, we
Pretty noticeable.
got blocks. Oh yeah. I don't know, it's scrolling so fast you can't see them, but here, this one contained like 6 transactions.
Where's the? Oh, do you have? Do I have to turn on debug to be able to see the set in the when it adopts the header?
Ooh, yeah. I don't think that I have that logged for.
Normally, it's okay.
No, yeah, I only logged that when you mint the block, I guess. See, I need to find a way to modify that.
I mean, I would say I would agree. Most people wouldn't care. It's probably more like a debug, or on the users. If you're as a non-operator, it's probably more of a debug thing. I would think because it seems like a little verbose for normal users. This feels like actually a pretty good level for normal users because it's live enough that I have I'm seeing the data go by, but it's also not so much that I get lost in it.
Yeah, I do worry it's gonna be noise like, well, because I only have one connection going here. This is just my laptop to GCP. I bet GCP is like a disaster. Well, actually, no, never mind. It isn't because it's not like logging when it's telling other peers about things. So maybe this one's probably the biggest disaster. No, even that's not so bad because again, it's not telling when it's notifying other peers.
Okay. Well, what are you thinking? Well, seems like we maintained our 1 second block time or whatever. I'm at height 444, 445, 446, 47. Oh no, I had 2 446s. Cool. What happened there?
You had two 246s?
I had 2 messages for height 446. I got a trace remote. Seems like maybe someone asked me about height 446. Yeah, I
Yeah,
just
that
saw
is.
2 messages about it.
It's interesting that you saw 2 messages though. You should only see one because you're only connected to one peer.
Yeah,
I think.
Yeah, that would mean that. Yeah, I only see messages. So anytime I send a message to a peer, I see in the like peer IP address. Yeah, under
Anytime
the,
you
the
send.
so I'm sorry, under in the logging messages, there's like CTB blockchain peer handler chain synchronizer.
Yep.
But anytime chain synchronizer sends a message, it's printing out the peer and then the IP address. So like
Yes.
every connection to a peer, I should see the IP address of the peer in the log. Yes.
Yeah.
To at least.
Yeah, there might be a couple logs that don't include that because they're located elsewhere.
Yeah.
But
Okay.
for
Well,
the most,
then, yeah, I only see one IP address, so I am only connected to one. It'd be really cool. We should maybe that's a good thing for like the dashboards to be able to like interpret the log or somehow connect into the to dynamically or somehow provide a description of the topology of the current application. I know that's like it feels advanced, but it feels like I could make a robot that would just watch this and look for that peer and then like draw a picture about what my topology is, like my local topology name.
our mempool is indeed like, well, it's growing and shrinking, but it's not like going in either direction out of control.
Nice, cool. Yeah, I'm pretty pretty steadily sitting at like 2 kilobytes per second, or 2 kilobits per second.
Yeah, let's see.
I'm sorry, 2 megabits per second. I apologize. I misspoke.
What do we got going on in here? I feel like it's not refreshing.
Hmm. How are you? What are the size of these transactions, or how do you want to test scaling?
Oh yeah, the data is currently empty for all these transactions, so they're probably very small.
Yeah, want to just like see if we can put like a, I don't know, 100 or 256 bytes or 512 bytes or something, just like the output of a hash function.
Yeah, let's see if we can hack that in while it's running. We are gonna have to restart in order to like test the change, but
That's good. Restart the chain, or just restart the broadcaster?
it's like all the nodes will have to restart because like in this little utility, I haven't saved the state of it. So if I were to relaunch it, it would try to spend from the first block again.
I see. Okay. No problem.
I do want to do. I want to fix that eventually, though. Okay, so
I mean, before we change it, then is there something you want to do before we like have to take it down and spin it back up?
No, because I mean, like no matter what I do, we're gonna have to do that. So.
We're going to change it. Yeah, that's what I was thinking. Okay.
So forget how to even do this with the Latin 1 data stuff.
Does it have to be Lat 1 data, or is it? I think we maybe the validation was only that it had to be an array of byte now.
Not yet. Fernando's pull request needs to be merged still.
Oh, okay.
Yeah.
Never mind. Okay, I see.
Okay, so let's just say. What am I doing?
Well, here you can only do up to 120. I would just say like generate an array of 127 bytes, like just like array dot, length, whatever, and then just like interpret that as a Latin 1 string. It's like the easiest way.
I have access to. I wonder what I can
just build
get here.
Scala.next.
Oh,
yeah,
heck yeah. Let's go. Okay.
And then you're going to need the array.fill, right?
I could just do this. Unfortunately, my IntelliJ is still suffering. I don't know if it's going to figure all this out. Oh, look at that. Transaction. Why doesn't it like that? Because this needs to be... Oh, why did it all break?
Well, your equals sign above.
Yeah, there we go. Man. And then I just need
And
this.
give a length.
Hopefully that's good. Okay, so this should add 100. What's that?
Well, I was going to ask, is it complaining about length implicit?
I think it.
Yeah.
I think the imports just take a little bit.
Okay.
Yeah, there we go. Okay.
Oh, there we go. Okay.
Okie dokie. So now it should generate transactions with 127 bytes of data in each of them. Okay. We could also introduce some complex... never mind. I don't want to change the proposition. That makes the addresses all funny. Okay. Well, that should hopefully work.
Next time.
Yeah. Okay, do we want to change anything with the speed? Like how many transactions per second? Or just leave it as is, see what this does, this change.
Yeah, let's see what this does. I was gonna say maybe we can do one more where we just like double it or something, just like the rate. This should be a pretty significant impact, right? We're changing the size of the transaction by probably 50%, if not 100%.
Yeah, this should directly impact network should directly impact this here. It shouldn't change our CPU processing.
Wait, did you just start it?
No. I'm just stopping things away.
Oh no, never mind. I'm sorry. I was sitting here watching some little tool downloaded an update, and I saw it happen on my monitor, like my network monitor. There's just this huge spike in it. I was like, "What the hell's happening?" My network usage went from 0 basically to like 100 megabits per second over 5 seconds. Jeez.
Okay, I think I've got all of mine shut down.
Alrighty, I have joined. I'm done. Yep.
Okay, so now I'm going to just restart on the GCP VM, and I'll get everyone a timestamp here in a second. I'll put that in the chat. Come on. Let me copy it. Okay. So that's our timestamp. I'll put this here in the chat. Okay. Now I'll update that for me. Everything else should stay the same. It's just the timestamp that needs to change for now. Where else? Over here.
This is a silly. Yeah, can you put it in the because I can't click on it when it's in that chat. Thank you. Good launch.
Yeah, I'm just wondering if maybe what if you wait to launch until we're at like height, whatever, and we have a bunch of transactions and it's got to then bootstrap.
Cool. Yeah, let's
with
do
transactions. Okay, cool.
We're gonna see if we can maybe hit like height 1,000 or 500 or something. I mean, 1,000 might take a minute.
Yeah, we'll play it by ear. We'll wait until we get bored. How about that?
Yeah, there you
go. Okay, so I got the GCP VM running. I got my local laptop node running. I don't have the Raspberry Pi running. That's why there are no new blocks. So, where'd it go? Okay, global slot 460, so it's super far behind. That's okay though. Actually, it's almost not okay. It's not quite 2 epochs, but.
Oh, I was actually going to say it should actually fail if you don't produce. I guess the first epoch you're okay because you have a block in that epoch. But yeah, if you don't produce a block in the second epoch, that should be a failure condition for the node for starting the.
Yeah.
Yeah. You have to have at least one block per epoch.
All right, so now let me start up the transaction generator. And again, same number of transactions per second, but we are increasing how big each transaction is. So probably doubling the size at least. I don't know exactly, but bigger. Okay, so we got transactions going now, roughly 1 per second. I see them being received here on my local node. Let's see what Google Cloud's not happy. What happened? That's not good.
This is the data.
lost connection with someone. What happened? This is invalid character.
I thought, is it really, we can just like do a stream of bytes? Okay. I thought it would work. Jeez. Well, I think there's a Latin 1 alphabet. I think that thing might have if you look at the Latin 1 data type, it might have an alphabet associated with it. So maybe you can just draw 127 characters from that alphabet. Instead of directly, I thought it would work to just fill it with bytes. I guess that was silly.
I mean, I would have figured like
Yeah.
a 0 byte would be fine. Does anyone in the chat have a suggestion?
Can we look at the?
We could merge
Is
for
the
Nano's
Latin-
VR.
I mean, I'm down.
No, I'm just kidding. It would take a little bit of work to get that all merged in on all the branches.
Yeah.
Um,
Can we just look at the Latin 1 data type for a second?
oh wait, it's because of
What?
I'm just generating arbitrary random bytes, but 127 of them. So that's why.
Oh. Well, no. I'm sorry, why? Why is that a problem? Because it should be, it's not 127 bits. It is 127 bytes. Each character should be a byte. And I thought the entire, I guess maybe what you need to do, it's only the positive numbers, like it's the unsigned. Maybe that's what it is that it's not defined.
And I know this is bad. I'm going to do it anyway.
Yeah, whatever. I mean, it's the same thing, right? You could literally just have filled it with zeros, yeah.
127. I'll keep it safer. Go with 100.
Yeah, there you go. We're not right at that edge. Because I know we've had some off by 1.
All right. I don't know what's going to happen. I'm going to restart this.
Actually, to be safe, maybe do it all ones. Don't fill it with all ones instead. Because let's just make sure that's a valid character. Let's look at the Latin 1 chart. Because maybe that's what it is like. It doesn't. Maybe all zeros is like the null character, and it's freaking out. Latin 1. ISO 8859-1. Just rolls off the tongue. Let's see. 0, 0 is nothing. It's an invalid. Yeah, actually, that's why. There's 2 whole segments of invalid characters. My bad.
Gotcha. But is 1 okay?
1 is not. All 2s would be, let's just see, if you did all 3s would be fine. If you did all 3s, that should just be the number 3, I think. Like a set of all 3s.
Where did it go? Data bytes 3. I would have thought that this was going to be like the hard part of the broadcast. Yeah. Just figuring out what's a valid Latin 1 character for something that we're going to be getting rid of in, I don't know, an hour.
This is exactly the reason we're like moving away from tile. It was a good learning experience. Sometimes you just gotta bite the bullet and accept that there are better ways to do things, though.
Did you sneeze Ethereum?
I did. I sneezed.
It was like really subtle. I was like, did he just sneeze Ethereum? Like,
I mean, I love Ethereum. It was a really good learning experience. I think there might be improvements we can make.
What was I doing here? Yeah, I need to change this timestamp.
Yeah. Can we share that one again?
Yeah, let me post that here in the chat and then in the other chat.
Oh. It ends in 3693. Is it true?
Yes.
Thank you. Please work this time. I don't want to be embarrassed again.
It's annoying that just like, so obviously like something needs to catch that. Well, I don't know. What do we do? Because that means that.
What do you mean?
Well, why was that not
Oh.
rejected by the RPC?
You don't think that's where it was being rejected?
Like it made its way all the way to the Raspberry Pi somehow. Because that's where I was looking at the log, like that stack trace was in the Raspberry Pi.
Yeah, you do. Maybe it's because we use Latin 1.unsafe everywhere. Maybe we don't actually have the errors. So it's just always assuming it can be a Latin 1. And so it gets that far. Maybe that's actually...
Well, but
I
like
wouldn't surprise me if it's-
the size decoder, it would use like the size max unsafe, but max unsafe would throw an exception. It's like it, I don't know how it.
I don't know.
It's weird.
Well, things to keep us learning.
Yeah, sorry, I'm like distracted trying to think about that. Let's get back to what we're doing. Okay, so Raspberry Pi is going. It's making blocks. My local node is receiving those blocks. GCP is most likely receiving those blocks. Cool. Okay, so now I'm going to start sending transactions, and this time it's definitely going to work, everyone. Absolutely.
Please.
Come on, you can do it. There we go. So 2 of them got sent.
Don't crash. Please don't crash. You got this.
Well, it's still making blocks somewhere.
Okay. All right. Do we see them being picked up? Yeah.
Scrolls too fast. Yes, I see a set of, what is that, 4, 3? 3 items, I think? 2?
2, yeah.
Really big text.
Okay. Yeah, what's your, do you have a limit on the, or is it just like as many as it can fit?
Yeah, I think it's as many at the moment. It would be unlimited. I don't impose a block size limit at the moment.
Yeah. Sure.
Okay, what was I? Oh yeah, I wanted to see the mempool. What are you doing, mempool? Yeah, that's good. It's growing and shrinking.
Okay, that's great.
Awesome. What is our network monitor saying? Network monitor is very confused at the moment. That's just not true. Or maybe it is.
What block are we on?
Oh yeah, I forgot you're not even connected. I forgot about you, James.
It's okay. I didn't forget. I'm waiting, trying to see if we can get to 1,000.
We're at height 121.
Oof. Okay, well, maybe 250.
Okay.
Oh, it's going pretty. Oh, okay. Well, maybe.
Maybe 150.
Yeah, we'll wait. Well, I was thinking 200. I want to give. Well, there's another. We're supposed to have a transaction history thing. But
You know, maybe 140.
150 sounds like a good number.
I mean, it should be. Yeah, that's a lot of transactions that you got to fetch. It's, I don't know.
Okay, let's
70.
Let's see how our. What? Big blank block. Huh. But can we? Can you tell me the the timestamp one more time? Can you just read it to me? And did you
Uh,
change? Like the whole config is still, it's, I have 1666285083693
yep, that's correct.
-1 1.
Yep.
Yeah, and then 250. Why didn't that work? Do I need to delete something from my?
I mean, only if you started with this configuration and then stopped, but
I
even then,
did.
it should just.
Yeah, right. It should be a different temp file, I thought. Yeah, I keep getting. Oh, sorry, go ahead.
Like if the timestamp changed, then it would create a new Big Bang block.
Right, that's what I thought
So
too.
new storage. What's the error that it's showing you?
I'm getting in pre-computing VRF proofs and row values. Why am I pre-computing row values? What's the Yeah, I'm getting like a staking dir.
Yeah, I think that'll get created no matter what. I don't.
Okay.
Yeah, I don't handle that.
What's your canonical? Do you know your canonical head? Sorry, do like the head ID, the Genesis ID?
Or the
Is it easier for you to find?
Genesis.
Maybe look at the data
yeah.
directory for your. Yeah.
Do you
Does
see
end
that?
in- yeah, I got C3UG.
Yep.
Huh. Why am I not? Okay, if I just delete it though, it should be fine. In temp?
Temp Bifrost staking. Well, yeah, if you just delete temp/Bifrost, it'll delete all of the.
All right, let's try again.
I don't have a pre-computing VRF.
Yeah.
So I wonder, like, is the local
wanna-
sticker indexed? Or if
do you
you
wanna
want to like
see
share
my-
your screen, we can look. Yeah.
Yeah, this is really weird. Wait, oh, it is. Oh yeah, it is. I'm sorry, this is something to present. Share screen, that's how we do it. It's going to be infinity. There we go. Yeah, see, this is what I keep. And
I think I know the issue. Like, so you haven't connected to a peer yet, but the global slot suggests that it's like what 4 epochs in the future right now.
Okay, makes
so
sense.
I need to figure out how to deal with that. Why is it pre-computing right then?
Oh, I see, for epoch 6. Oh, I see.
So I mean, at least it does crash if it doesn't find any blocks in the epoch that it expects. But
yeah, that's good.
at the same time, I want to be able to, bootstrap. It's weird that maybe I didn't. Yeah, I don't know what the deal is.
Oh, well, the goal was to break stuff. We broke it.
Good news, everyone. We broke it.
Nice.
For science.
Cool. Well, actually, I'm gonna, if you don't mind, I'm gonna leave it to you to wrap up, because I gotta go pop this other meeting. I'm already a little late. So
Yep. No,
thank
no
you,
problem.
everyone, and
Yeah, appreciate you being here, James. Thanks.
Later, man.
Yep. Alrighty, y'all. Well, here I can throw this back up. Let's do a quick recap before we close out for today. Basically, our goal was to do what we did last time, where we have multiple nodes running, one of them being a Raspberry Pi, one of them being up on Google Cloud, and then a couple others running on local developer laptops. So we got those all running, we got them connected and talking. And then what we did was we added transactions into the mix. So again, like transactions, they are like the main piece of data for a blockchain. Like they consume data, they create data. So we wanted to see how things performed with a lot of transactions in the mix. It looked like it, met our expectations for this little scenario that we set up. The Raspberry Pi was able to receive transactions that I'm generating on my local laptop, and those are being funneled all the way through the network up to GCP and to the Raspberry Pi. So they were all talking. We got transactions going. I think that they're still going. Yeah, our mempool is still growing and shrinking. Our transaction generator app is still broadcasting transactions, and I think that they're being included. So that is all good news. The one thing that we did finally break was when I had James wait to start the bootstrapping process, so that it was, I don't know, a couple hundred blocks behind, and we realized there's some sort of issue in the mix there that prevented it from bootstrapping because it found empty epochs technically. So we need to figure out how to stop it from failing just because it hasn't bootstrapped from any peers yet. So yeah, a couple more things to do. We do want to continue pushing this further. We want more complex transactions in the mix, potentially with more data, and then also more of them, because we're right now operating at 1 transaction per second, and we obviously want to go a lot faster than that in the real world. So that's what we got going today. A Raspberry Pi can receive and process transactions. So it's a relative success because we got things working and we correctly broke them, which was another objective for today. So that was good. Before we wrap up, does anyone have any questions in the chat? Definitely feel free to leave them in here. We'll give it a couple more minutes here and see if we can answer some things. Let me throw that up there. You can go and ask away. I'm also going to throw some music up into the mix here while I take a sip of water. Guess I should show the actual Raspberry Pi running. Here it is in all of its glory. You can see that it is still receiving transactions, still including transactions in blocks. This one at 2. See, like it's still running after height 400. So I'm happy with that. Achievement unlocked. Okay, y'all. I think that's a good stop point for today. Nice little experiment. We're gonna keep pushing on this. We want to keep going with this series and do more interesting things, especially like off the grid stuff. But it's cold right now. I don't want to go outside. Unfortunately, it's gonna keep getting colder. I don't know what to do about that. We'll figure it out. Anyway, it's been fun, y'all. Again, I just want to throw a reminder, we have a grants program, and if you want more information about that, you can hop over to this thing that I'm going to show on the screen here in a second. This one. Yeah, our link tree. You can find more information about the grants program there. But otherwise, if you want to find more information about us, scan this QR code or go to the link tree. That's linktr.ee/Topl_protocol. You'll find links to our Discord, our Twitter, our LinkedIn, our Twitch, our YouTube, our GitHub, everything. You'll find it all there. And yeah, I mean, that's it for today, everyone. It's been real. Have a good day, y'all.